All right, this is sort of part B of an algebraic proof worksheet I'm working with you. Something that we use to get started on learning how to prove things is starting out with algebraic proofs. And algebraic proofs very often are just sort of solving equations and justifying each step. Because that's what we do in a proof, is we justify, here's how I know this, here's how I know that. We are basically going for a conclusion, trying to arrive at something, and giving our evidence along the way. So, looking at this picture, this one's not really laid out formally. It doesn't say given and prove, but we're kind of assuming that this is our given information right here, is this picture. Okay, and apparently what we're trying to prove is this, because this is where it ends. So that's what we would be, if it had been written out at the top, it would say given segment HJ with I between H and J, and then it would tell me these lengths, and then it would ask me to prove this. So this is just a very informal proof. All right, so if we're assuming this is all something that we already know, the stuff up here, then we know that I is between H and J. We have specifically a postulate that says if you have a point I between 2 points H and J, then this is true. It's called the segment addition postulate. Okay, so here's the segment addition postulate. Sometimes when I go over the segment addition postulate, and also its sort of cousin, the angle addition postulate, I refer to it as part plus part equals whole, because that's what it's saying. It's saying this part plus this part equals the whole thing. So that's what you got here. Whole thing comes from the two parts added together. Now, what happens next? Well, next we're just substituting. We're putting a 7x minus 3 in place of hj, a 2x plus 6 in place of hi, and a 3x minus 3 in place of ij. So that's the substitution property of equality. Now, on another video, I mentioned that with substitution, very often you are, or pretty much always, you're taking two equations and putting them together in one. Really, it could be two or more. And what we have here is this, they're sort of implied. Like I said, this one's not really laid out formally, so they're sort of implied equations. It's implied that hi, the length of hi, is 2x plus 6. That's an equation, and then we're plugging it in. So this is the second thing, is putting that in, putting it in place of hi. It's implied that 3x minus 3 is equal to ij. Here's my second equation. I'm plugging it into ij. It's implied that 7x minus 3 is equal to hj, and I'm plugging it in there. So we have taken one equation and then other equations that say these parts can be plugged into that equation and put it together. So we're putting together multiple equations, and that's substitution. Next, from here to here, nothing changed on the left. On the right-hand side, we just combined our like terms or simplified. So I'm just going to say simplify. It's good enough for me. You could say, you could maybe make a case for associative property, that instead of associating the 2x plus 6, we decided to associate the 2x plus 3x and got 5x. There's a few things you could say here and not really be terribly wrong. Really depends on what your teacher wants you to say here. I'm fine when it's just reducing a fraction or putting together like terms or just doing a little bit of a simplifying, just do a little cleanup, just saying simplify. Next step, looking from here to here, what changed? Well, there was a minus 3 and a plus 3. Now there's just a plus 6. What really changed the most obvious difference is 7x minus 3 became just 7x. So what had to have happened? We have to have added 3 to both sides. Now this is an example of not seeing the work. You don't have to write it in. I'm just writing it in to show you. You don't see that work, but that's what happened to both sides. So my answer is, for reason is addition property of equality is what happened. I added 3 to both sides, and here's my result. The reason is always written next to the result. Let's see what happened next. To get a 2x from a 7x, it looks like I subtracted that 5x from both sides. Again, you don't have to show it, and it's generally not shown, but that's what's happened, is I have subtracted something from both sides. So subtraction property of equality. Last but not least, I went from 2x to 1x and 6 to 3. What did I do? I divided both sides by 2. That's division property of equality. And I am done. Okay, looking down here, identify the property that justifies each statement. If you're just using this, if you don't have this worksheet in front of you or you haven't tried it, if you're just using this to help you, please feel free to pause it and try them yourself. It's always the best idea is to see if you can try something yourself first before someone else shows you, especially if you have a little experience with it. So this one, m is equal to n, so n is equal to m. Okay? Now, I'm going to tell you what sometimes people want to say this is. People sometimes want to say this is reflexive. It's not reflexive. This is reflexive. Reflexive literally says something is equal to itself or congruent to itself. There's no change between the two sides. They are exactly the same. You also notice there's only one equation, or in this case, congruent statement. It's not if this is true, then, and another one over here. It's just one statement. Something equals itself, or something is congruent to itself. That's reflexive. This one has a hypothesis and a conclusion. It has this statement and says if that statement is true, then this statement is true. The two sides aren't the same. One says m, one says n. What's different here from the hypothesis to the conclusion is the order. Which one is on which side of the equal sign? That's symmetric. Remember that line of symmetry that goes down through the middle of the equal sign. That's what symmetric property says, is that there's a line of symmetry down the middle of your equal sign, so it doesn't matter which one you put on which side. So this is symmetric property. And technically it's symmetric property of equality, and so is it transitive property of equality, etc. But for some reason we generally say the property of equality more on the addition, subtraction, division, multiplication ones, and just say property for the others. And I think the reason for that is that there are other properties that use the word addition, or other theorems, postulates that use the word addition or subtraction or division, and so we're trying to be really clear that we mean that specific addition property, the one that says do whatever you want to do to one side as long as you do it to the other for addition, for subtraction, etc. All right, this one, look at what's different. This one's a really kind of a tricky one. Now, symmetric property, the order changes, yes, but notice you had two statements, and the two opposite sides of the equal sign are what flip-flop. We've only got one statement here. The flip-flop is just the name of the segment. That is not symmetric property because we only have one statement. We're not trading sides of the equal sign from one equation to the other. Okay? If we were, it'd be like this and then flip it over for the next one. This is just taking advantage of the fact that the name segment KL is the same. It describes the segment, same segment as the segment name LK. So it's just changing up the name, but it's talking about the same thing. It's saying something is congruent to itself, just like we did over here for reflexive, and that is reflexive. And last but not least, here we have an example of the transitive property, or you could call it substitution on this particular one. Remember, for transitive you have to have two equations where one side of each equation is the same. So we have equals Q equals Q. And you take out that middleman and say, oh, then P is equal to -1. And that's exactly what has been done. So I can call that the transitive property because we had two things, P and -1, both equal to the same thing, which was Q. And so we said then they must be equal to each other. Now you could also consider that substitution because you could say you have P is equal to Q, and then you happen to know that P is -1, and so it's like you're putting a -1, well, I'm sorry, you know that Q is equal to -1, so you're putting it, I'm just going to start again. P is equal to Q, and we know that Q is -1, so we're saying, well, I can put a -1 here then. So substitution would also work on this one. One thing to note is substitution property is really a property of equality. So generally we don't have any substitution with congruence. So the fact that I have equal signs is another reason that I could also use substitution here. And that covers the rest of this worksheet. Hopefully it has helped you a little bit.